today I'm just going to give you a brief overview of the puzzle half-life activity. So in class when we do this, we use puzzle pieces which have two sides that are clearly different, a front and a back. At home, maybe you have a puzzle, maybe you don't. You can use coins, you can use a candy like M&M or Skittles that has a letter on one side and nothing on the other. If you don't have anything, there's a piece of paper in your kit that has a bunch of little alphas on it for alpha decay, which is what we're simulating here. So you can cut those out and use the alpha side and the blank side as pieces that you're flipping as well. Okay, so what we're doing here is we essentially have a sample. I'm starting with 10. You're going to start with 50 pieces. I just didn't want to spend the whole video counting. Okay, so you're going to start with 50 pieces that are all right side up. So at time 0, no half-lives, you'll have 50 pieces. In my case, I have 10, right? So then you're going to collect them all up and kind of shake them up and then just drop them, all right? So when I did that, I end up with 5 pieces that are still right side up and 5 that are upside down, okay? So these are my ones that have decayed. So now after one half-life, which is one toss, I have 5 pieces left, all right? So you're gonna count from what you have left of your 50, right? And then you'll take those and do the same thing again. So you're gonna take them and just drop them. All right, now I have 2 that are face up and 2 that are upside down, right? So that after 2 half-lives, I have 2 left, okay? And then we'll do it again until there's none left that are right side up. All right, so now I have 1 and 1. All right, and then I'll keep doing this one until it lands upside down, right? So it's still 1. I'd write that in my next row. 1. I'd write that in my next row. 1. Write that in my next row. Oops. All right, it landed upside down that time. Okay, so now I've got 0. Once you get to 0, you can stop recording. You don't need to fill all of the rows in the table. Okay, and then once you're done that, you're going to do a little bit of graphing to see what the decay rate looks like for alpha decay over a certain number of half-lives. Recorded all of my numbers in my data table here. So at 0 years, that would be no half-lives. I started with 10. Again, this number will be 50 for you. Okay, and then one half-life for C14 is 5,730 years. Okay, so after I did one toss, that's one half-life, we have 5 left. Okay, and then the number of years that I've put in here increases by 5,730 each time I do a toss. Okay, so mine, remember, it landed on 1 multiple times in a row, all right, and then we ended up with 0. Okay, so for you, you're going to start with 50 and do that until it runs out. And then the same thing with trial 2, you're going to start all over again with 50 and do it again. And then you're going to average those two, right? So that's going to be what you got from trial 1 plus what you got from trial 2 divided by 2. Okay, now once you've done that, you're going to copy the number of years into a Google Sheet. Okay, and you're going to copy your average. I don't have an average because I just did it once, but you're going to copy your remaining C14s over here. Okay, and then let me move this down. There we go. All right, and then you're going to highlight this and do a scatter plot. So remember that tutorial is on Google Classroom if you need a refresher, but we go to Insert and then Chart. All right, and the default for me was a line chart. That's not what I want. I want to see all of the individual points, okay? So that's my scatter plot right there, okay? And then under Customize, I can add under Series, I can add a trend line. So remember, the last time we did linear. This clearly is not linear, right? If you look, that line going through there does not look right. This is actually an exponential, right? So if you do an exponential, it looks much better, okay? Your curve should look better than this because you'll be starting with more C14s. So the more we start with, the better the curve is going to look. But this is, you know, a pretty clear exponential, okay? If you want to, you can show the equation and use that to figure out how much you need for each for the questions at the end, but it's also fine to just use the curve and to estimate. And if you are having trouble estimating, it may be useful to add grid lines. okay? So if you add minor grid lines, that will give you a better, it'll give you more lines to be able to estimate the values, okay? So if you go back here, you're gonna do your data table, make your graph, make sure you attach your graph to the assignment, and then once you get down here, you're gonna use your graph to estimate these things. So that's why it's important that you have the graph, and adding the line helps with that. Okay, so if you have questions, please let me know. This shouldn't take you too long. So if you're spending more than like 20 minutes on this assignment, send me an email and we can figure out what's going on. Okay, so that is what I want you to do. And this simulates the decay of carbon 14 to nitrogen 14, which I explain up here in the introduction. All right.